So, hi guys, I'm Shubham Agrawal, and in today's session, we are going to cover 8 previous year questions on recursion. Okay, so in the previous lecture, we have seen about recursion. Okay, so let me just recap it. So, what is recursion? So, recursion is function calling itself. So, if f1 is there, then we are calling f1 again until some base condition is reached. Okay, so here some base condition will be there, so it is to stop the recursion. Okay, so let's try one example of factorial which is covered in the previous lecture. So if we want to calculate the value of fact of 4, okay, so 4 is compared with 1. So 4 is not less than equal to 1. So base condition will not be satisfied. So we will call for f of fact of 3. Okay, then it is also not satisfy the base condition. So we will call factor of 2. Then factor of 1 will be called. When factor 1 is called, then base condition is satisfied because 1 is less than equal to 1, hence 1 is returned here. Okay, then 2 into 1, which is 2, will be returned to factor of 3. So it will be 3 into 2, that is 6, and it will be returned to factor of 4, which is okay 4 into 6. So it is 24. Hence, for n equal to 4, our answer will be 24. Okay. So in this, we have a problem of size 4, and we are trying to reduce it into the problem of size 3, which is smaller than 4. Okay, and we are doing until base condition, which is this, okay, is reached. Okay, so this is about the recursion. Let's do some gate questions on this. Okay, so this question was asked in gate 2020. Okay, in which one second. So in which we have two functions f1 and f2. Okay, and we have to find the value of fun of 2. So let me write fun of 1 here, fun of 2 here. So we are calling it by 5. So here a static variable I is there, which initial value is 0. Okay, then we are calling fun 1 of 5. Okay, so let me calculate. So this is the value for this fun 1. Okay, static variable, because it is, so its the scope will be local to this function, but its lifetime will be throughout the program. Okay, so here we are calling fun1 with the value of 5. Okay, so when here first the I get incremented, so I will be 1, and then fun1 of 4 will be called, and after this again I will be get incremented, so it will be 2. So again fun1 of 3 will be called, again I will get incremented, and fun1 of 2 will be called, then again I will get incremented, then fun1 of 1 will be called. Okay, now again I will get incremented. Okay, 5, and fun1 of 0 will be called, and when fun1 of 0 is called, okay, so we are just returning its value, because and 0 is not greater than equal to 0, so its value is we are returning I here. Okay, so here I is returned, so I is a static variable, so its value got updated to 5. So 5 will be returned here, then 5 will be returned here, same here, here, and here also. So we will just update the value 5 in this value I, so I becomes 5. Okay, so here also, so the current value of I is 5 for fun1. Okay, so let me erase this. Okay, now let me also erase this. This is the fun1 function, and now we are calling fun2 function, in which the value of n is 4, because n minus 1 is happened here, so it is 4. And this 4, when n equal to 4, then we will again call this f1 function with value 4. So now with value 4, this will be called. Again, I will get incremented to 6, fun1 of 3 will be called. Then again, I will get incremented to 7, then fun of 2 will be called. Again, I will be incremented to 8. Then fun1 of 1 will be called. Again, I will get incremented to 9, and fun1 of 0 will be called, which return the value of I, which is 9. Okay. So 9 will be returned here, 9 will be returned here, and 9 will be returned here. Okay. So answer, now we will add this 9 to I. So I is 5, so we will add it to 9. So it will be 5 plus 9, that is 13. Okay. So here, so sorry, 5 plus 9, that is 14. Okay. Okay, so let me write it something like this: 0 plus 5 plus 9. Okay, so previously the value was 0, then it is 5, then now it is, we are adding 9 to it. Okay. Now the current value of I for F1 is 9. Okay, now let me erase all this. Okay, now after fun2 of 4, we will call fun of 3 will be called. Okay, now fun1 of 3 will be called, and again I will get incremented to 10. Then fun1 of 2 will be called, again it will get incremented to 11. Then fun1 of 1 will be called, again it will be incremented to 12. Then fun1 of 0 will be called. Okay, so here we have incremented, so I becomes 12, so 12 will be written here, 12 here, then 12 here, and then 12 will be written here, and we will add 12 here. Okay, and the current value of I is 12. Let me erase all this. Okay, so we have fun of 4. So now fun 2 of 2 will be called, and so fun 1 of 2 will be called here. Okay, so fun1, so I will get incremented to 13. Then fun1 of 1 will be called, then I will get incremented again 14, and then fun1 of 0 will be called. Now this will get returned because it is, so base condition is, means when we will be in this function if n is greater than 0, so n is 0, so we will just return the value of I, which is 14. Again 14 is returned here, so we will add 14 here. Okay, so let me erase all this. Okay, so the current value of I is 14 for fun1. Okay, now fun1, fun2 of 1 will be called, and for that fun1 of 1 will be called. So one second. Yeah, 1 will be called, and here we just increment the value of I, which is 15, and fun1 of 0 will be called. Okay, so the value of this uh, is 15, value of I, so 15 will be returned, so here 15 we will add. Okay, and after this F1 gets over. Now fun2 of 0 will be called, and when fun2 of 0 will be called, so it is not greater than equal to greater than 0, so we will just return the value of I. So value of I is 5 plus 9 plus 12 plus 14 plus 15. So let me add all this. So 9 plus 5 is 14, 12 plus 14 is 26 plus 15. Okay. So it is 14 plus 41. Okay, so it is 55. So here 55 will be written here. Again 55 will be written here. Again 55 will be written here. And then again 55 will be written here. Then again 55 will be written here. So the correct answer for this question is 55. Okay. So here our answer will be 55. Okay. Now let's do one more question. Okay, so it was asked in GATE 2017 set 1. Okay, in this we have one function foo and one function bar. So when we invoke this function foo of 3 and bar of 3, then what will be the result? So we have to select one of the option from here. Okay, so let's see foo of 3 first. So when foo of 3 will be called, okay, so x is equal to 0, value is 3, so 3 greater than 0. So yeah, it is fine. So we will enter to this loop. Then foo of 3, so val minus minus, so it is postfix decrement. So first the value will be passed to function 3 and then it will get incremented. So value is currently 3, but first 3 will be passed, then the value get decremented. So value become 2. So here when foo of 3 will be called, then foo of 3 will again called. Then again foo of 3 will be called because we are calling it in a recursive way, and it will be called until the stack is full. Okay. So it will be called infinite times. Okay. Means but we are using the call stack here. So call stack has certain limit. So this program will terminate and it will give segmentation fault error. Okay. Segmentation fault error because uh, here here the function stack will get full. Okay. Okay. So foo of 3 will be called. Okay. So first of foo result will abnormal termination. Okay. So abnormal termination. Okay. So this is about the foo function. Let's take talk. Let's now see what bar function will be. Okay. So let me erase all this. So in bar function we are passing value in. So bar of 3 is there. Okay. X is 0, val is greater than 0. Now we are passing bar of 2. Okay. So bar of 2 will be there. Okay. So if we draw a stack here, then bar of 3 will be there. In that bar of 2 will be there. If now bar of 2 will call bar of 1. So bar of 1 will be there. Okay. Now when bar of 0 will be called, so now the so 0 value is not greater than equal to 0. So this if the while condition will not satisfy and 0 will be returned. Okay. So here 0 will be returned to this. So bar 1 value is 0. So 0 will be added to this x. But again, this while loop will run because since this is a local variable, so this is not get updated. So val is again 1 only. Okay. So again, so val is 2 only. Okay. So when this, sorry, 1 second. Yeah. So when bar of 0 is returned, so its value is 0. And currently value of val is 1 and 1 is greater than 0. So uh, again bar of 0 will be called. Okay. And again it will return 0 and again bar of 1 will be called, then bar of 0. So it will result in a, so bar of 0 will be there when it will get over again bar of 1 because here while loop is written. So while, so here's written, it is written something like this, while 1 is greater than 0. So this 1 is greater than 0 is a true condition. Okay. So it will always, so this will result in an infinite loop. Here the stack will not get full because we are pushing bar of 0, then we are popping bar of 0. We are pushing bar of 0, we are popping bar of 0. So here the abnormal termination of program will not happen, but this will be an infinite loop. Okay. This will result in infinite loop. Okay. So our correct answer for this would be abnormal termination and infinite loop. So foo will be abnormal terminated because function stack will get full, and it will result in infinite loop because here in while there is a condition 1 is greater than 0 which will be always satisfied, and we will only have at most 4 entries in this stack. So stack will not get full, so we will not get any abnormal termination error, but instead it will be infinite loop. Okay. So we have to press Control C after this to stop the program. So option C is correct. Okay. So let's now do one more gate question. So this question was asked in GATE 2015 set 2. So in this question, we have a function, okay, in which we have to call this with this input. Okay. So let me write the input A, B, C, D, then space is there, then E, F, G, and H. Okay. So let me give the addresses to this. So let me give A as 1000, then it will be 1001, it will be 1002, it will be 1003, the space will be 1004, 1005, 1006, okay, 1007, then 1008. Okay? And currently A is pointing to this because we have passed this string to this. Okay, so A is pointing to A, that is 1000. So first foo of, so we are writing here the address, so 1000 will be called. Then we will check the value at this 1000 place. So 1000 value is A, and A is not equal to space, hence we will go in the foo, means we will go in the if condition, and we will call foo 1 A plus 1. So it will call foo of 1001, and it will also put a character. So this put character means it is putting the value of this character which is pointed by A. So A star means this value A. So A will be printed here. Okay. Then when foo of 101 will be called, then value at 101 is B. So B is not equal to space. So again we will enter in that condition, and foo of 102 will be called, and B will get printed. So it will not print until this function is over. So we are just writing it here. Okay. Then foo of 103 will be called, and here also it is not equal to space. Okay. So foo of 104 will be called, 1004 will be called, and here when we called it is also not equal to space, and when we called sorry, one second. Yeah. So here when we called foo of 103, then it will print B. Okay. And when 10004 will be called. So this is pointing to space. Okay. So when it is space, so it will not enter in the if condition. Okay. So we will stop here, and it will return to this function. And after returning to this function, the statement after that function will get executed. So this put character star A will get executed, and D will be printed on the output. And when we return to this function, C will be printed. When we return to this function, B will be printed. And when we return to this function, A will be printed. So our output would be DCBA. So the correct answer is D. Okay. So let's move on to our next question, in which we have fun of and. Okay. So we have to call this function with fun of 5. So before that, here we are using fun of, and we have a loop also. So let's start with in a reverse way. So first let's calculate the fun of 0 value. Okay, so fun of 0. So here there is no condition for 0. So let's start with fun of 1. Okay, so fun of 1 is when n is equal to 1, then we return x. So x is 1, so we will return 1. So it will be 1. Let's calculate fun of 2 now. Okay, so fun of 2 will be so fun of 2, x is 1. Okay, and n is not equal to 1. Okay, so we will enter into while this for loop, and in this k equal to 1 and n is less than equal to 2. So because here n is equal to 2. Okay, so it will execute one time. Okay, so it will result in x. So x value is 1. So 1 plus fun of 1, k is 1, into fun of, so one second, so fun of 2 minus 1, that is 1. So 1 is fun of 1, and 1 is 1. So 1 into 1. So it will be 1 plus 1. So x will be 2. Okay. And when we again go to the loop, so k will be 2 now. And 2 is not less than equal to n, because n is 2. So 2 is not less than 2. And so here we will stop, and the value of x is 2, and the value of x is written here. Okay. So hence fun of 2 value will be 2. Okay. Now let's calculate fun of 3. Okay, so fun of 3 will be, okay, so it will be x plus fun of 1 into fun of 2 plus fun of 2 into fun of 1. I have just opened the while loop here because it will run 2 times, and this will be the result. Okay, I have just opened this for loop here. Okay, so we have the value of 1 and 2, so we will just calculate it. So x is 1, 1 into 2 plus 2 into 1, so it will be 5. Okay, so fun of 3 will be 5. Okay, what will be the fun of 4 value? So it will be, so let me just erase it. So it will be fun of 4 will be x plus fun of 1 into fun of 4 minus 1, that is 3. Then fun of 2 into fun of 4 minus 2, that is 2, plus fun of 3 into fun of 1. Okay, so we have all these values here, so we will just add it. So value of x is 1, so 1 plus fun of 1 is 1 into 2 into uh, fun of 3 is 5, then fun of 2 is 2 into 2 plus 5 into 1. So it will be 1 plus 5 6 plus 4 plus 5, so it will be 15. Okay, so fun of 4 is 15. Okay, so let me erase this. Okay. Now let's calculate fun of 5. So fun of 5 will be x plus fun of 1 into fun of 5 minus 1, that is 4. Then fun of 2 into fun of 3, 5 minus 2, that is. Then fun of 3 into fun of 2, 5 minus 3 will be 2. Then fun of 4 into fun of 1. Okay. Now value of x is 1, value of 1 is 1, fun of 1 is 1, value of fun of 4 is 15, plus then 2 value is 2, 3 value is 5, then 5 into 2, and then 15 into 1. Okay. So it will be 1 plus 15 will be 1 plus 15 plus 10 plus 10 plus 15. So it will be 15 plus 15 and 10 plus 10, 20, 30, 40, 51. So the correct answer will be 51. Okay. So this will be our output. Our correct answer is 51. Okay. Yeah. So the answer to this question will be 51. So here we have calculated in the reverse way. We first calculated fun 1, then fun 2, then fun 3, then fun 4, and after that fun 5. Because we need those values first. Okay. So if we go on into the recursive way, then we have to first draw the recursion tree. So it will be little bit complicated. So solving this question in this way will be very efficient and very easy. Okay, to understand. Okay. So answer to this will be 15. Now let's move to our next question. So in this question, we have a C function in which we have to call get6, and we have to tell how many times this get function is called. Okay, before returning to main. Okay, so we have a main function, and in that main function we are calling get of 6. So we have to tell how many times this get of 6 is called. Okay, so let me just erase it. Okay, so here I'm writing get of 6. So when get of 6 is called, so get of 5 will be called because we are calling n minus 1, then n minus 3. So it will be get of 3. Then we are calling get of 5. So it will be get of 4 and get of 2 because 5 minus 3 will be 2. Okay. Then here it will be get of 2, and here it will be get of 0 because 3 minus 3 is 0. Okay. So here it will be 0. Then we are calling get of 4. So get of 4 will call get of 3, and get of 4 will call get of 4. And here we have get of 1 and get of minus 1 because 2 minus 3 will be minus 1. Then we have same thing here, get of 1 and get of minus 1. Then get of 0 will not call anything because here and 0 is not less than 1 plus 0, 0 is less than 1. So we just return. Okay, we are not calling anything. Then we have gate of 3 which call gate of 2 and gate of 0. So gate of 0 will not call anything, but gate of 2 will call gate of 1 and gate of minus 1. And gate of 1 will call gate of 0, and gate of 1 minus 3 will be minus 2. Okay. Here also gate of 0 will be called, and then gate of minus 2 will be called. Similarly, here also gate of 0 will be called and gate of minus 1 will be called. Oh, sorry, minus 2 will be called. Okay. And then here also gate of 1 is there, so gate of 0 will be called and gate of minus 1 will be called. Minus 2 will be called. So after this, whenever n is less than 1, so we will not call anything. Okay. So so this many times this function is called. So let me just change the color of my pen. Okay. Okay. So let me count the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Okay. So here I'm missing something. So 1, 2, 3, 4, 5, 6. So here I'm missing this. So it will be 25th. Right? Okay. Gate of 3 I have missed. So there are 25 times this function is called. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yeah. So the correct answer will be 25. So the answer to this question will be 25. Okay. Let's do our next question. So in this question, we have a C program in which three functions are declared, and in the main function, these functions are called. So here, when f1 is called, so we have x plus equal to, this means we are at it is written something like this. Okay, then f of 3, then f of 2. Okay. So when this f1 is called, so f1 has a local variable 25 and it will be got incremented. It is post incremented, so it will become 26. So 26 will be returned here. X value is currently 1, so x will be 1. When we call f2, so f2 has a static variable, so static x equal to 50, and we will get it will get incremented by 1 and we will return it, so it will return 51. Then f3 will be called, and here the global x will be used, which is 10, so 10 into 10 will be 100, so 100 will be returned here. And then f2 is called again, but this time since it is a static variable, so we will just update the previous value, so it is 51, so 52, so x will be incremented, it will become 52, then we will return this x, so it will be 52. Now let's add all this, so 51 plus 52 will be 103, 103 plus 100 will be uh, 203, and 1 plus 26 will be 27, so 23 plus 203 is, so it will be 230. Okay. So 230 will be the correct answer. So the answer to this question will be 230. Okay. Yeah. So this is about this question. Okay. Now let's try to do our next question. That is this. So it was asked in GATE 2014 set 2. In this question, we have give value q up to 2 decimal place such that f of q will return q. So if we pass q in this function, then it should return q. So here there is a one condition. If we pass x, if this condition is satisfied, then we will return this x. So we have to find the value of x for which this condition is satisfied. So here absolute means mod, and here x into x means x square minus 3 should be less than 0.01. So we should have to satisfy this condition. So let's try the options. So here 1.73 is there, which is the, I think, uh, root 3 value is 1.732. Okay, so its value is this. Okay, so root 3 value is 1.732. Okay, so it is approximately this. So let me just multiply it, means let me square this value 1.73. So let me just multiply it. So it will be 9, 1, 2, 3, 5, okay, 7, 1. 2, 49, 1, 5, 7, 1, 2, it will be 12. Then we will have, sorry, 1 into 3, 7. But, okay, let me just add this. So, yeah. So 5 1 plus 3 9. Then we have okay, 2 plus 9 plus 7, that is 9. And then we have 1 plus 1, that is 2. So there are 2 decimal here, 2 decimal, so it will be 6. So our result would be 2.9929. So this is the value when we multiply 1.73 into 1.73. So when we subtract it with 3, so this value gets subtracted by 3. So it will be 3.00002.99929. When we subtract this, so it will be 2.999. So 10 minus 9 1, and it will be 7, and it will be 0, then 9 minus 9 0, then 2 minus 2 0. So it is 0.71. Okay. So here our answer is 0.71. Okay. So which is less than is 0.01, because this will be in minus because we are subtracting this from this, so it will be minus. So but we are taking the absolute here, so it will become plus. So this is the absolute value which compared with 0.01, so it is less than. So as this condition will be satisfied, as the A option will be correct. And when we test for other option, then it will be incorrect, because then the result will not be satisfying this condition. Okay. So the correct answer is A. So if you have this type of question, you can just satisfy this option in this question. Okay. So here our first option gets satisfied. So hence we take, because we know that this is a multiple choice question and only one option is correct. Okay. So here we got lucky because we have to test only one option, and the correct option is 1.73. Okay. Let's move to our next question. So here we have a C function in which f is there. Okay. And it is telling which one of this true. So first one is function returns 0 for all values of j. Okay, let's see. So we have a static variable 15. So if I equal to j, then we will print something, and then we again call with the same value I, that is 15. And when this value get written, then we will return 0, else we will return 0. So in this function, if the I is equal to j, then we will do something. We will go in this if condition, otherwise we will return 0. So the function returns 0 for all values of j is wrong, because for j equal to 50, it will enter in the if condition. Okay. So it will not return 0 for all values. So for j equal to 50, it will not return 0. So this option A is false. Then we have the function print the string something for all values of j. No, for j equal to 1, it will not print. It will just return 0, because j is not equal to I. So this is also false, because here all values are mentioned. But for some values, it will print something. Okay, and that value is 50. So the function will return 0 when j equal to 15. So it will also be wrong. Okay, because for j equal to 50, it will print something, and then it will again recurse. Okay, so it will not return 0 here. So hence it is false. The function will exhaust the runtime stack or run into an infinite loop when j equal to 50. So let's see whether this is true or not. So we are calling f with 50, j is 50, value of j. So 50 is compared with this I, so 50 is equal to I, then we will print something. Then we will again call 50, because value of I is 50. Okay. So again this will call 50, and again this will call 50. Okay, so this will happen. Yeah. So it will be infinite. Okay. Condition. Infinite loop condition means here the call stack will get full, and we will get segmentation fault error. So yeah, it will exhaust the runtime stack. So this option D is correct. So our correct answer would be this option. So our correct answer is this D, and all other options are wrong. Okay. Let's move to our next question. that was asked in GATE 2013. In this, we have to print the value of so this function is called by f p comma p, and in this p is initialized with 5 before call, and we have passed first parameter as passed by reference, and second parameter is passed by value. So here we have passed x by reference and int c by value. So we know that when we pass by reference, then this the value of this p will be so x will be alias name for this. So p and x will be the aliases of each other. Okay, so they will refer to the same position, means same file. Okay, so when we called f of 55. Okay, so here we have to tell when f of 55 will be called. So what will be the answer? Okay, so here C will get equal to 5 and C will get decremented to 4. Then C is not equal to 0, then X will be incremented. So when we increment X, so this will get incremented, so it will become, uh, 1 second. So it will become 6. Okay, then it will call 6 comma 4. Okay, then C equal to 4, it will get decremented and it will call uh, then sorry, first x will get incremented, so it will become 7. It will call 7 comma 3. Then c equal to 3, it will get decremented to 2, and then we will increase the value of x by 1. It will be 8. Then 8 comma 2 will be called, c will be decremented by 1, and then x will be incremented, so x will become 9, and then f of 9 comma 1 will be called, and c will is 1, and when we decrement it, it will become 0. And now c equal to 0 will satisfy, and we will return 1. So this function will return 1 to previous one. Okay. And in this, since we are returning the value into x, so x is currently 9, since it is passed by reference, so it will be 9 into 1. Okay, and 9 into 1 will be returned, so its value is 9. So 9 into 9 will be returned by returned to this function, and this function will be 81, and 81 will be returned to this. In this, 9 will be into, so 81 into 9, and this will be returned to this. This will be 9 into 9 into 81, so it will be 9 to the power 4. Okay, so 9 to the power 4 is 81 into 81, so it is 1 8, then 8, and then 6 4, then it will be 1 6 5. So 9 to the power 4 will be our answer, and its value is 6561. So our correct answer would be this. This code will return 6565 as the output. Okay, yeah. Let's do another question which was asked in GATE 2011. Okay, so in this we have an unsigned int and function name is foo, in which two parameters are there, which is also of type int, and we have this condition: if n is greater than 0, then we return this. We are calling this function with some updated value of n and r. Then if it is not satisfied, then we will return 0. So this else condition is our base condition. If it is not satisfied, then we will return 0. Okay, now we have called foo of, okay, so foo 3 4 5 comma 10 is called. Okay, now first we will do so it is greater than n is greater than 0, so n modulus r will happen, so 345 modulus 10 will happen, so it will so sorry, so 345 modulus 10 will happen, so it will give the result 5, because the remainder will be 5 and we divide it by 10. Okay, and 5 plus, and we will call 2 with the updated with the divided value of this, and with when divided by r, that is 345 divided by 10, then it will be 34 comma 10 will be passed. Again, we will take the remainder of 34 and 10, which will be 4, and 4 of, when we divide this by 10, so it will be 3 comma 10 will be there, and then here the remainder will be 3 when we when 3 and 10 we have taken the modulus of them. Okay, then foo of, so when we divide it by 3, so it will be 0, comma 10. And since n is not equal to 0, so 0 will be returned. So the value of this will be 0. So 3 plus 0 will be 3, and 3 will be returned here. And 4 plus 3 will be 7. 7 will be returned here. And 7 plus 5. Okay. So we have 7 plus 5. So it is 12. So the output of this function is 12. So the correct answer is 12. And this is our correct option. Okay. Let's do the same similar question, but this time the value is different. In this, we have n equal to 513 and r equal to 2. Okay. So let's do. So first, foo of 513 comma 2 is called. Then it will give. So when we divide, take the modulus by 2, so it will be 1 plus foo. When we divide it by 2, it will be 256 comma 2. Now, since it is divisible by 2, so the remainder will be 0. Then we will call 128 comma 2. Again, the result would be 0 because remainder is 0. It is divisible by 2. Foo of 64 comma 2 will be called. Again 0 because it is divisible. Then foo of 32 comma 0 will 32 comma 2 will be called. Then again 0. Foo comma 32 sorry 16 will be there here. 16 comma 2 will be there. Then again 0 plus foo of 8 comma 2. Then again 2 divided by 8, that will be 0. That will be 4 comma 2. That will be 0. That will be 4 foo of 2 comma 2. Okay. So here also it will be 0 plus foo of 1 comma 2. So now the when 1 comma when 1 2 when 1 modulus 2 will happen, so it will be 1 plus 0 comma 2 will happen. Now when this will happen, so it will return 0. So here the value will be 0. So 0 plus 1 plus 0 plus 0 0 0 0 up to 1. So 1 plus 1, that is 2. Hence our answer would be 2. Okay, so here the answer will be 2. Okay. So if we represent this 5.3 in binary, so it will be 0. So 1 second. So it will be 1 0 0 0, then 0 0 0 0, then 0 1. So this is the binary representation of this 513. So in this we have two ones. Okay. So this code is computing the number of bits which are set in this in its binary representation. So here 2 bits are set, and our answer is 2. So this code is doing that. So this is just an observation because we are taking remainder and we are calling it with the division. Yeah. So it is computing the number of bits, the number of set bits in the number. So this code. Hence the answer is 2. Okay. So let's do one more question. So in this question, we have C function and we have to return the value of f of 5. This question was asked in GATE 2007. Okay, so we have value of 5 is there. Okay. And we have a static variable r whose value is currently 0. When f5 is greater than 3 is compared, then r is set to n. So r will be 5 and then it will call f of 3. Okay, and in this we will add the in this result we will add 2. Okay, now when f of 3 will be called, so again r is static, so it will be 5. Then 3 is not less than equal to 0, so it will not return 1. So we will see this condition is satisfied or not. So 3 is greater than 3, so this will not be satisfied. So we will return f of n minus 1. So that is f of 2 plus r. So we will add r here because since it is a static variable, so we will update its value later. Okay. Then when f of 2 will be called, again 2 is compared with 0 and 3, so these two conditions are not satisfied. So f of 1 will be called and r will be added in the result of this. Then f of 0 will be called here, and when we called f of 1, so again this condition is not satisfied. This is if condition is not satisfied, so f of 0 plus r will be called. So here also r will be added, And then we called f of 0. Now this condition is satisfied here and it will return 1. Its value will be 1. And here, since the value of r is not updated and it's 5 only until f of 0. So we will just add 1 to this. So value of r is 5. So 1 plus 5 is 6. So 6 will be written here. 6 plus 5 will be 11. So 11 will be written here. And then 11 plus 5, it will be 16. And 16 will be written here. And 16 plus 2 will be 18. So this f of 5 will return 18. Hence the value is 18. Hence the correct answer is this. So yeah, so in today's lecture we have solved many gate questions based on recursion. So I hope now you have a proper understanding of recursion. Okay, because recursion you can expect at least one question from this exam. So one question will definitely be there in the gate exam. Okay, so just practice the questions. The more question you do, the more uh, so the more you practice, the more question you will able to do in the gate exam, and whenever you face a new question, you will able to do that. Okay, so yeah, so this is it for today's session. So thank you guys.